Before you understand batteries or electricity, the most important thing to understand is energy. What exactly is energy? Uh, the technical definition is energy is the ability to do work. But if you look at it at a more fundamental level, energy is a property of the universe that permeates all kinds of scales. You'll find energy at inside the nucleus of an atom as well as at a planetary scale. And so you might have more energy stored in a small volume at the lower scale, at the lower the scale, and the higher the scale, the energy density, so to say, reduces, but the quantity increases. So now, what? Uh, how do we use this to do meaningful work? So first of all, there is a very clear correlation between energy consumption and GDP per capita, which can be a proxy for prosperity in a roundabout way. And if we want to get more of the world uh, to a higher living standard, we will have to increase the overall energy consumption of the whole world. So that is easier said than done. How do we harness this energy? How does this harnessing of energy work? So step one is you have to generate energy. And by generate energy, I mean not in the sense of the law of conservation of energy, generate in the sense of getting large amounts of energy out of some sort of material. That is not that hard. What is hard is doing that in very large quantities or in controlled quantities, doing that cleanly, doing that safely, doing that cheaply, and doing that timely or whenever you want it. So that is generating the energy. This is the supply side of the equation. But what after that? What do you do after you generate the energy? So you need to convert that into a consumable form. And this is an even harder problem because energy has a tendency to sort of dissipate or uh, basically cause chaos. And it's very, very hard to control it. Similar to how you might want eggs to become omelets, but they become scrambled eggs because that is the nature of the universe where things tend to move towards disorder. So, just as an example, uh, petrol, when you burn it, is great for generating heat. But how good is it at converting that heat into mechanical motion of the pistons inside an engine and then using that to move your car forward? Not very well. So, if you compare the efficiency of an electric motor with a petrol engine, and you compare the input energy that's eventually converted into mechanical energy, there's a vast difference. So as you can see, there's clearly uh, electricity is somewhat better than hydrocarbons like petrol for some tasks. Now, as it turns out, it is very good for a lot of different tasks, uh, especially at the end user consumption level. We are talking about the demand side over here. And if you look at the energy consumption by top sectors in the top five countries, energy consuming countries, it would be US, China, India, Russia, and Japan. So you see somewhat of this kind of a picture where transport, industrial usage, and residential usage top the chart. And a lot of these applications can very easily be electrified, and they can be much more efficient when done using electricity. That is something people realize. So what is going on is a massive, massive electrification of the economy. What I mean by that, what it means is that the final consumption of energy can be in different forms. It can be in the form of petrol as in a car, or it can be in the form of electricity as in your phone or in an electric car. And what we are seeing is a massive shift towards the distribution of energy sources and that final consumption towards electricity, so that the final consumption becomes much more efficient in a lot of different